Hello and welcome to this UniTaster On Demand, where today we're going to be exploring university courses in Earth Sciences. My name is John Sheik. I'm here from UniTasterDays and I'll be hosting this event. And with these events, we try and provide instructions for students considering all aspects of university and all aspects of university courses. So with these, we cover generally reasons you might wish to consider this course, what to expect on it, application tips, and an overview to potential careers as well. And our expert today is Dr. Amy Gough, who's joining us from Royal Holloway, University of London. Amy is going to deliver an introduction to Earth Sciences, and I'm always conscious you've tuned in to hear from her, not from me. So with that, I'll pass things over to Amy, please.
So hi, as John said, I'm Amy Gough, and I'm a lecturer in the Department of Earth Sciences at Royal Holloway, University of London. I've been lecturing for 3 years, and I mainly look at the regional sedimentary systems that occur around Southeast Asia, which is why we've got an image of Southeast Asia instead of the typical UK one on our Earth on the slide. I'm also the emissions lead for the Department of Earth Sciences. So later on in the talk, I will discuss a little bit about the university application side as well, and just some hints and things to consider if you do decide to apply to study Earth Sciences at university. So if we kick things off by looking at what Earth Sciences actually is, as it is a subject that isn't usually directly offered at A-level, but it does encompass a lot of familiar aspects of other science subjects such as geology, maths, chemistry, and many more. So put really simply, Earth Sciences is the study of the planet we live on, and it brings together all of the spheres that occur on this planet. So this includes the geological, such as the Lithosphere and the Asthenosphere. It includes the atmosphere, the Biosphere, the Hydrosphere, and the Cryosphere. And in more recent years as well, scientists have also used their skills to look at planets beyond the Earth. So we also now include Planetary Sciences in Earth Sciences. So I'll go through each of these subject areas in turn and give you a few examples of some things that you might study in each of them. So we'll start by looking at the lithosphere. I myself am a geologist, so this is my domain. And the lithosphere is this brittle outer part of the Earth. So it encompasses the crust and the solid uppermost mantle. So we're talking here about this kind of hard and rigid layer of the Earth or any other rocky planet. And our lithosphere is broken up into different tectonic plates, both oceanic and continental, and this forms the basis of plate tectonics. So the study of the lithosphere gives us an insight into the history of our planet, such as these plate tectonic movements. We can also use it to look at past climates, or even to give us insights into interesting catastrophic events such as the asteroid that wiped out the dinosaurs. We like to consider that the knowledge of the past is really essential for understanding what might happen in the future. And we use this to analyse risks such as earthquakes or potential catastrophic events that might occur. So if we move down further into the Earth, we reach our weaker and hotter Asthenosphere, and the Asthenosphere is also slightly more stressed. So the Asthenosphere is ductile in nature, but is mostly solid. So you can think of it slightly like plasticine. However, there are areas where the heat flow is increased and it leads to the generation of magma. So that's when our Asthenosphere melts. When it melts, it leads occasionally to volcanism, like you can see on this slide with this really impressive volcanic eruption. And this video is just taken from Global News. And again, it's these potential hazards that we as Earth scientists want to look at. The next sphere to consider is the atmosphere. And when we talk about the atmosphere, we're talking about this gaseous envelope that surrounds planets. So our atmosphere here on Earth is a really delicate system, and it's predominantly made of nitrogen and oxygen. However, it's often the greenhouse gases that are integral for us to look at. So I'm sure we're all aware of the negative effects that carbon dioxide can have on our atmosphere. But this picture actually shows some Earth scientists collecting data on methane emissions from cows. And cows are actually one of the biggest contributors to global methane. It's really important for us to have a record of these emissions, as well as to understand where this methane is coming from. So we can try and work out ways to kind of mitigate and reduce the amount of methane entering our atmosphere. Methane emissions don't actually stop at cows. There are quite a large percentage of humans that actually produce methane when they breathe. So if you ever see a scientist out and about collecting methane measurements, maybe with these big sticks in front of cows, ask if you can have a breathe onto their device and see if you're one of these people that produces methane. I can tell you that I'm one of these people. So I'm also contributing negatively to climate change. The next sphere is the Biosphere, or sometimes referred to as the ecosphere. And this contains all of the ecosystems or life on Earth. The term itself has a geological origin and stems from the work of pioneers such as Charles Darwin. And many people don't know this, but Darwin was actually a geologist before he found his passion in biology. So in the case of Earth sciences, the biosphere is considered to have been around since early life. So there's evidence on Earth of bacteria being around over 4 billion years ago. So in terms of geological time, that isn't so long after the formation of Earth. So for me personally, one of the most exciting periods of life was back when the dinosaurs were roaming around on the surface of the Earth. And this picture shows an imprint of some dinosaur footprints. You can see them picked out, or these large ones picked out in this slightly lighter colour on this fallen block of rock. This picture's taken from just outside of the town of Moab in Utah in the western United States. And these footprints have been interpreted as theropods, more specifically as an Allosaurus. And you can see this really colourful cartoon rendition of one here. Of course, we don't really know the colour of the feathers, but it is nice to consider them as these quite colourful beasts. The Hydrosphere, so our next sphere, considers all of the water on Earth. Again, it's a term that stems from geologists, in particular an Austrian geologist, Edward Suess, who recognised evidence for the supercontinent of Gondwana and the related supercontinent ocean of the Tethys. We know that water is one of the most precious resources on Earth. So only about 2.5% of water on Earth is freshwater, and about 0.25% of that is available for human use. Not only for drinking water, but we also need water for things such as irrigation as well. There are areas of our planet that have extended droughts and dry seasons, and there's lots of inventive ways to kind of solve these water shortages. But this video from the BBC shows one of my favourites. So this is the formation of glaciers or stupas in the Himalayas. So what they do is when they have their rainier seasons or their wetter seasons, they pump their water into this into one place, and the cold temperature forms these man-made glaciers in the mountains. And these build throughout the colder winter months until spring arises. So spring is where the dry season would usually start, but in this instance, this glacier is melting and it produces fresh and relatively clean water, both for drinking use, but also for irrigation. And so farmland can continue to be sustained throughout the drier months. And this actually feeds quite nicely into our final sphere on Earth, the Cryosphere. And this is all of the solid state water, so ice on Earth. So we're talking here about glaciers, ice caps, or even snow. So whilst there are overlaps here with the Hydrosphere, because it's still a state of water, it does have certain really distinct properties that make it worthy of being a subject area within Earth sciences all on its own. So for example, understanding the key drivers of deglaciation is a really important part of understanding climate change. So the equipment shown in this picture is measuring the reflectance of solar radiation off of this ice. something referred to as albedo. And you can see that often when we go out and do these experiments in the field, we have some of the most fantastic research assistants, such as these penguins. And so finally, just a quick note on earth sciences being used outside of the Earth. We have previously successfully used earth sciences to gain an insight into the surface of Mars, for example. So we've used it to recognise where water previously acted on sedimentary systems on the surface, or to recognise that Olympus Mons is a massive volcano. However, excitingly, it has recently been announced that NASA has funded 2 missions to Venus. So this is something that hasn't been attempted in over 30 years. And this NASA announcement was very shortly followed by an announcement by the European Space Agency, the ESA, and they have also funded their own mission to Venus, a mission called Envision. A mock-up of the craft could be seen on the slide here. And the lead scientist of Envision is an earth scientist based in the department here at Royal Holloway. So earth scientists can take you beyond the Earth all the way to Venus in space. So of course, before you start any degree, it's super important to consider how you're going to be learning to make sure that it's a learning style that suits you. One of my favourite things about earth sciences is that as it considers the world around us, the world itself acts as our natural laboratory. And this means that a proportion of your degree will be spent outside experiencing this natural laboratory. So the photos on this slide are a really good representation of the types of fieldwork you might do in your degree, from getting to look at really impressive rock formations to hanging out on waterfalls and even sampling the quality of water in river systems as well. So in addition to this outside laboratory, you'll also get the chance to spend a lot of time in labs inside as well, as earth sciences is a very practical based subject. In fact, when you're studying, you'll often find that an hour-long lecture comes accompanied by 2 hours of a practical session. So you can really get hands-on with the subject and learn kind of the practicalities about it. This is true across all of the sciences, but getting your hands dirty is really one of the best ways to understand and learn the subject. It also adds a bit of exciting variety to your degree as well. So why should you study earth sciences? There's a lot of sciences out there, and this is kind of a combination of all of them. Well, the reason to study earth sciences is that it really focuses on the key challenges that face us in the world today. So I'm just going to describe 3 really quickly here, but there are 3 among many. The first one is the energy transition. So at the moment, we're moving from a society that relies quite heavily on fossil fuels. So we're looking at hydrocarbons, but we're hoping to oversee a transition from hydrocarbon usage into renewable energy. So solar energy, hydroelectric, wind power, all of these exciting new technologies. But we really need earth scientists to oversee this transition. We're also in a period of human-induced or anthropogenic climate change. And this has been so pronounced, and our effect on the planet has been so pronounced, that we've actually entered a new geological era, the Anthropocene. And as I mentioned in relation to measuring the methane from cows, we really need to have a record of all of these variations and changes that we're causing, so we can start to build models on how to mitigate this. We're also in a time where our population is very rapidly expanding, and we're also simultaneously using more and more resources. So we need to ensure that people have access to these resources and that this access is sustainable. So this picture shows a rice paddy from Bali in Indonesia, and in Indonesia, rice is one of their main crops. So for these rice paddies to be sustainable, we need to make sure that the water coming in is high enough quality, and we also need to make sure that there are nutrients within the rice paddy. And all of this links back to being an earth scientist, to make sure that you've got all of these in place in order to have a sustainable system. So as earth sciences looks at all of these key issues, It means that the potential career pathways are incredibly diverse. So this diagram is taken from the Geological Society of London. So it does have a slight geoscience spin on it, but it does give a useful overview of some of the careers that you could go into if you do earth sciences. So you can see there's quite a lot of careers related to the energy industry, such as hydrocarbons, so kind of traditional, or geothermal, such as renewable. There's a lot of environmental related degrees, such as environmental protection or environmental geochemistry. And there's also these space related degrees, such as planetary geology. It's easy to look at diagrams like this and think, wow, that's a big subject with lots of different subject areas to go over when you do your degree. But it is important to note that you won't be expected to study all of this throughout the entirety of your degree. And often you'll find when you do an earth sciences degree, you're specialised from the second year onwards. So you'll spend the first year doing an overview of different subject areas, and this will give you a chance to find the area that you really want to go into, where you want to forge your career. And then from your second year, you'll be able to choose modules that focus in that or in one or two of these areas. You might be asking at this point, but how employable is earth sciences? Well, if we have a look at the government list of UK shortage occupations, so these are occupations where we really need people to go into, you'll find the following earth science related professions listed. So there's geologist, geoscientist, geochemist, mining geologist, geophysicist, hydrogeologist, working in nuclear decommissioning, so that's the safe disposal of nuclear waste, and engineering geologist. So quite a lot of geo careers, but a huge amount of professions listed there. So of course your degree won't finish immediately. So you might be asking yourself about the long-term career opportunities. Earth scientists are really essential to meet the future demands of society. Therefore, there's always going to be a need for earth scientists to exist in society. So, for example, as we use more and more renewable energy, which is really good for the planet, we do need to mine elements that are critical to develop these technologies. So we need earth scientists to find sustainable ways to get these elements out of the ground in order to support more development of these technologies. We also really need people as policy influencers, so people that understand the science that will guide government and guide policy on things such as climate change, the environment, or natural hazards. We also need people to work out how to store energy. So after we generate all of this energy from renewables, we need to find places to put that energy where it's going to be sustained. And these are just 3 examples of many future careers. So if you are interested in doing earth sciences, you might want some application tips. So the first tip is to specifically mention what drew you to the subject. So are you particularly enthusiastic about saving the planet? Do you really want a role in policy guidance? Or are you just super keen to see no more fossil fuels used in the future? Make sure that this kind of motivation and this rationale comes across in your personal statement. Admissions tutors, such as myself, are also super keen to hear about your related hobbies. So I particularly like it when people have experience in just being outside. So if you've done your Duke of Edinburgh, maybe you were part of Scouts or Woodcraft folk, then all of this is really good stuff to include in your personal statement. Other amazing things to read about is if you've had any policy experience, maybe you were a member of the United Nations Youth Association, maybe you've done some work with local government. All of this is just really fascinating to put in there. Or maybe you have an affinity to helping the environment. Maybe you've organised litter picks or been involved in litter picks in your local community or in your school. Maybe you have cut out using plastic in order to protect the environment. All of this kind of information adds up to a great personal statement. And the final thing that I want to mention is if you're worried about the sciences, then don't. You usually only need 1 science subject, and this usually can include geology or maths to apply for earth sciences. And then whichever university you go to study earth sciences will have modules in the first year to catch you up on the necessary science subjects that you didn't do at A-levels. As it's such an applied subject, people often find the science aspect of the degree a lot easier than when they did it at school level. So the amount of times we have people say, oh, I found chemistry really difficult, but as soon as I started doing it in terms of geochemistry or in applied manner, I'm really enjoying it and I'm finding it just really fascinating to do. So just to conclude the whole presentation, if you like maths, the sciences, geology, or the applied aspects of physical geography, then Earth Sciences is the degree for you. So I hope this helped give an overview of the subjects, and I hope it leads to a few of you going to university to study Earth Sciences. Thank you.